We are in a series about the general linear model, and we have begun working our ways through the various models with examples. In this video, I'm going to talk about the two-factor randomized design and model. Subjects are randomized to J times K different experimental conditions. J and K here are each factors, so if you take the number of levels of J and the number of levels of K and multiply them together, that's how many different cells, that is places where you can assign participants, there are in the study. Each score is the sum of the mean, the effects of the two factors, the interaction between these factors, and the residual that is unaccounted for by the study factors. So we have here a response of person I in level J of the J factor, in level K of the K factor, and we think that their observed score is the sum of the baseline, which is the mean across all scores, plus the effect of being in level J of the J factor, plus the effect of being in level K of the K factor, plus the effect of being in the interaction of those two at each level of J and K, or at that specific level of J and K that that participant is in, plus the residual of person I in the Jth level of factor J and the Kth level of factor K. So let's take a look at a design in which we looked at in a past video, and that is where we had guinea pigs, and the guinea pigs were randomly assigned to a dosage condition. Here in this box plot, you can see it a little bit better. We have a dosage condition, low, medium, and high doses, and we have a medium for delivery, and that is either through orange juice or through vitamin C via ascorbic acid. Those were the two different mediums for delivery. So the two factors here are the supplement type and the dose, the method of delivery and the dose. Those are the two factors as we talked about here in these factors. We have a factor here for supplement and a factor for dose, or vice versa. It doesn't matter really which way you call those. I also note that in this design, the guinea pigs were randomly assigned to both the type of delivery and the dose at random. And so we would call this a completely randomized design. Here I've called it a two-factor randomized design, but it could be completely randomized, or it could be randomized on one factor and observational on another, or it could be observational on both factors. And this model would stay just the same either way. So looking at the common issues regarding analysis that we look at, remember that one of them was when you put interaction in the model, that you then look first and focus on the interaction, as we can see in this graph. So down here, if I go all the way to the analysis of variance table, all the way down here, you actually can see here all of the different terms in our model. We have supplement, we have dose, we have the interaction, we have residuals. So when we look at the linear model, we have supplement, we have dose, we have the interaction, and we have the residuals. So a person I, one of the guinea pigs in this case, I call it a person, but it's a guinea pig in this example, guinea pig I is only going to be in one level of supplement. And so if they're in the first one, then this little j would become a 1. If they're in the first supplement, but the second dose, the medium dose, then this beta would be beta sub 2. And then this alpha beta would be alpha beta 1, 2. So that would indicate the different effects for that particular guinea pig. Because if that guinea pig was in another cell, in a different supplement, or a different dose, or different for both of those, then the effect alpha would change, the effect beta would change, and the interaction would change. So each of these are applying to the cells in the particular design we have here, in which we have 1, 2, 3, 4, 5, 6 different cells that guinea pigs could be assigned to. So each of those alphas, betas, and alpha betas depend upon which particular guinea pig we're looking at and which combination of conditions they're in. So one of the common analytic things that we do is we focus on the interaction if we've put it in the model. Now, in this particular case, it looks like there's interaction both descriptively, as I see up here, and inferentially, as I see down here. And because there is interaction, then I'm not going to go to main effects, but rather I'm going to build my confidence intervals based upon tetrads. And that's what's happening here. Looking at the effect of orange juice versus vitamin C in this first one here, looking at that effect for a medium dose, and looking at the effect of switching from orange juice to vitamin C for a low dose. And I like to focus on those two individual numbers, and then we can put them together and get boundaries for the difference of the differences. That is, the difference in the effects of switching from orange juice to vitamin C, the difference of the effect in medium and low doses. So we focus on the tetrads. Again, for the residuals, we look at the sphericity, which in this case is homogeneity variance. Why? Because both of the factors here, both supplement and dose, are between subjects factors. So since they're between subjects factors, remember the rule is that I can look at a between subjects analysis for sphericity and for homogeneity of variance, and that applies to each of the between subject factors. What about interaction? When both of the factors are between subjects, interaction's also between subjects. It means that when you take any particular cell and compare it to the other cells, all the guinea pigs are in one and only one of the 6 conditions. So this is what we looked at here. Independence is taken care of because we're randomizing the guinea pigs to condition, and I'm assuming all the guinea pigs were chosen independent of each other. It wasn't like we took an entire single family of guinea pigs and we assigned them to each of those conditions, looked at the residual in terms of sphericity, that is homogeneity variance for between subjects, and normality. And then remember, we looked at interaction and moved on to tetrads. So that's an example of the common analytic principles being applied to a 2-factor randomized design and model. In the next video, we'll take a look at 2 different designs because they're basically the same, the randomized block and repeated measures. So I'll see you there.